Okay, let me share my screen.
Okay.
So this is session number 7. The topic is enhanced scanning for small object for 3D reconstruction with monocular camera. And we also have a design and build an application for investigation on social network by Kufang Yao, but he has submitted his presentation online. So this will be available on YouTube. Zeyu, I'm giving floor to you.
Okay, thank you, Anna. Oops. Okay, I think I need to change the screen that I shared. Hold on a second, sorry. Can you see my screen?
Yes.
Okay, thank you. Hi everyone. I'm Zeyu Chen, and in today's presentation, I will introduce my capstone. And my capstone topic is enhanced scanning of the small object for 3D reconstruction with molecular cameras. This is what I will follow in this presentation. Okay, for a problem statement, 3D reconstruction can be applied in many fields, such as transportation. Something like auto drive. The currently command use 3D scanning method require the user to record videos around the object. There are problems with this scanning method. For example, the object can be scanned. To be scanned, need to be logged on clear planes, and not allowed surfacing. Not all the surface information for the object can be scanned, such as the bottom of the object. At the same time, this scanning method is not friendly to scan for the small object. On the other hand, the cost of 3D modeling of the real-world object is high, and the scanning for those 3D modeling require professional device. How to allow people to obtain 3D reconstruction results in a convenient, fast, and low-cost way with good user experience is the problem that this project needs to solve. For motivation, the first point is that 3D reconstruction requires expensive specific device. I will show this part later. In order to achieve a goal of low cost, this project used a command molecular camera. The second point is that handheld scanning can obtain more comprehensive information about object. And this is more reasonable way for human-computer interaction. This project plan is where the user can directly see the modeling process to dedicate which angle to scan and can stop the scan earlier. For background, I will introduce some concept. The first is 3D reconstruction. It is the process of capturing the shape and appearance of the real-world object. People capture the information by using a 3D scanner, such as a camera, radar, or LiDAR. The second is image segmentation. It can distinguish different sub-areas. Other algorithms can select useful area from those sub-area for processing. 3, ORB, it is a fast local feature detector. ORB use the brief feature descriptor and are matched by the fast feature matching algorithm. Finally, SLAM. If ORB can give computers the ability like human to recognize the same object from different angles, then SLAM can let computers know where they are in the real world. When a mobile device starts from an unknown location in an unknown environment, it uses sensors to observe and local its position and attitude in 3D space during the movement process, and then build a 3D map, and according the information it collects to locate its position in the 3D maps. This project uses React to write web page as the user interface, which allow the user to join the same quantity of server in different devices, anywhere and anytime. I'm using JustFit in the front end for object tracking. JustFit is a simple computer version library that can run in web browser. For the backend, I use the Flask framework as the server and did image segmentation on the backend by using U2Net. ORB SLAM and PCL as the core of the 3D reconstruction will be run independently. The project planned to use SFM, but after my research, I found that SLAM is more suitable for the need of this project. This is from the 2020 surveys of the 3D scanning market. You can clearly see that people spend more on hardware than other else. Just complete the 3D scanning task. This is why I use the molecular camera for this project, because almost all smartphones and more than half of computers have molecular camera. People can easily scan items with those command devices. This significantly reduced costs. Wang and Hauser in 2090s built video simulation models for enhanced object. This segment items by way for machine learning, which is an RNN mode. Look at the flowchart. I zoom in the first form in the right image. You can see they require user to mark the first form to segment the front end and the back end. It needs user to do too much interaction that are not suitable for my system. And U2Net, it is what I use in my capstone. It is a SOD framework. When you look at an image, your eyes automatically focus on the most important area for this image. The SOD algorithm can identify those areas. My capstone will use the U2Net as the image segmentation algorithm. SciMask. It is a method for performance virtual object tracking in real time. Although it is real time, it spent too much computing resource. If I use it in my capstone system, the system has not spread research for 3D reconstruction. I compared a lot of algorithms that can perform the 3D reconstruction. There are two most classical ones, SFM and SLAM. SFM is very slow and not suitable for my system. For a better user experience, the system need to give user real-time positive feedback. ORB SLAM 2 is very fast, and it is very suitable for my system, so I choose to use it. In order to describe the computation, I did the object checking in the front end. This architectural picture shows the overall structure for my capstone system. The system is mainly divided into 3 parts. First is the web front end, responsible for interaction with user. The Python Flask backend, responsible for the image segmentation, and independent subsystem responsible for 3D reconstruction. By using this system, we can achieve a real-time running speed about 30 FPS. The first clamp use RM for segmentation is very slow, and the second clamp it is Utonet, which does not require the user to interact with it. And third is Simon Mask, which takes up a lot of computation. My method require no user interaction and achieve real-time feedback. Data collection. Since real-time feedback lead to a better user experience, data collection focus on collecting time-related data. The FPS will be recorded in the front end, and execution times will be recorded on the back end. And the questionnaire needs to be applied to the IRB, and due to the short cycle for this project, this data is not actually collected. This is the data I collected in this object. It was planned. In the project beginning, I planned to use the Utonet through the ONNX in the web browser, but some operator for the Utonet, the ONNX runtime is not supported yet, so it cannot use GPU in the front end. And if use GPU in a Python, you can get a result in less than 0.3 seconds. It is very, very fast. So I moved the object segmentation job to the back end. And in the front end, the object tracking task can be completed at more than 30 FPS. And in the ORB SLAM subsystem, it can run at 6 FPS in CPU. For the funding, this project reduced costs by using a molecular camera, and this reduce the cost of 3D reconstruction as molecular camera are very easy obtained in different devices. At the same time, it is found through experience that the method of this project can obtain real-time feedbacks and bring a better user experience to user. Okay, conclusion. As just mentioned in the funding, in addition to the cost reduction through the molecular camera and the high user experience by using real-time feedback, this project burns user fast server and convenient operations. Through the method for this project, user can obtain 3D modeling results convenient, quickly, and a low cost, and with good user experience. For the future work, the LK article flow method are using in the front end for object tracking. It is easy to lose the tracking target. Object tracking can be done using feature-based methods, such as like the ORB feature. And Usenet, it is Usenet are using in this system for image segmentation. It cannot run in real time. Those limited the speed of system. So in the future, maybe we can change it to the other algorithm to do more to get more speed for the system. And the last, web browser cannot obtain the camera information required for the SLAM system. The size of the input videos and camera information is assessed in this project, so I can get the template results. This key reference. Have any questions?
Thank you.
Thanks.
Thank you, Jerry. I am interested in the applications that this could be used for, because in one of your examples, you showed somebody on a tennis court.
Yes. Because I running the Microsoft Teams, so maybe it is very slow. So can I play the videos? You can see the application in the videos.
Mm-hmm.
Okay.
Will you have a demo of this at some point in your future work?
For future work, the demo for the future work?
Mm-hmm. Well, but the other reason I was asking is that this is a technique that's also used for vehicles. So I was pondering how you would be applying the technology that you're talking about.
Yes. How I apply the technology in my system?
Mm-hmm.
Yeah. So it actually is web actually is a computer version field. So I complied different technology to achieve one goal, just 3D reconstruction. It is little bit different with the auto drive.
Okay.
Yeah, because auto drive is focused on location. The need let the car know where the car in. So generally they use the SLAM system. It can get it can build a simple 3D map and locate it in the 3D map.
Okay.
Yeah. But my project is focused on 3D reconstruction.
Okay.
Yeah, it is a little bit different because the drive don't need to a complex 3D map. They just need to the key point for the location.
Okay.
Yeah.
Okay. Thank you.
Okay.
Jerome, do you have a question?
No. I do have a comment. I think it's very interesting topic and concept, and I would be very interested in seeing the future work and how this could be applied. But yeah, I don't have a pretty good presentation.
Okay, thank you. I think I can reshare the videos.
Thank you, Jerry. I can see it in the chat.
Yeah. Okay.
You'll now have a YouTube that you can refer people to when you're applying for a job.
Yes. It's very useful, I think.
Very good idea.
Can you guys hear the video's voice?
Okay.
Can you guys hear the video's voice?
No, I can't.
Okay.
Can anyone else?
No.
Not working for me either.
Let me jump to the demo. Okay, for the front end, it is very simple. User can do the object tracking. And when user put the items in the blue box and click stop, they can get the segmentation results as the output. I not complete the whole capstone object because the short developer cycle. So in plant, I won't put the 3D model as the output in the right, but in here, I just put the image segmentation. And for the for the ORB SLAM system, when user get the image segmentation result and sent to the ORB system, and ORB system can give the camera information results and build the point cloud. The collection of the point cloud. And after that, I plan to use the PCL to get the 3D model. But I spent a lot of time to do this job, and the capstone only have 10 weeks development cycle, so I'm not finished yet. So
So, so that's some cool stuff there. That's why it's so important for us to start encouraging students to start thinking about their work, their capstone by the end of their first year. Because how much time would you have liked to have had on this?
Actually, I learned a long time in the computer graphic, and I think the computer version is very similar as the computer graphics. So I'm not ready in the computer version. So I'm new of the computer version. So this first time I learned the knowledge about the computer version.
Okay.
So
I do have a question.
yes.
So like, who would this benefit? Like, what's the need? What is the business need for something like this? I understand, Morgan, you mentioned, cars,
Mhm.
but who would benefit from this? Like, is there a need out there for this type of technology?
Yes, this project is focused on the real world object reconstruction. And for example, this 3D game, they have a job focus on build the model, 3D model, like uh, the object in the game. So if you can get the result from the real world, it will reduce the workload for those jobs.
Oh, I see.
Yeah. And on the other hand, for example, Amazon, if you like the the product, if you can see the product by 3D view in the web page, and you can very helpful you to choose a product, right?
Okay.
Okay.
Yeah.
Oh, I thought that it might have some applications for some of the driving, for lane changing, if it's being used in real time. Are those possibilities?
Okay.
And I'm sure there are more that we don't know about. Jerry, you need to educate us.
uh, I'm newer for this field, I just learned 10 weeks for computer version.
Uh-huh.
Yeah, so for the auto drive, there are different way to recognize the road. For example, the light in the road. Yeah. And the auto drive need to carry about a lot of other situation. For example, the other card between use and uh the traffic light, something like this. So it's not my project is not focused on this, so I not learn too much on those fields.
Good learning experience.
I'm sorry.
Good learning experience for you.
Yes. First, I need a lot of mathematical knowledge to understand those systems. This first step is very important step, and is luckily I learned I think half of the mathematical knowledge for the computer vision by learning the computer graphic. And the second, you need to know the sensors, how the sensors work. For example, for the SLAM system, I need to know the camera information. You know, the field of view, something like this, to get the reconstruction results. If you don't have this information, you cannot get a correct result. That's it.
Okay, thank you.
Thank you.
I don't have any more questions. I just want to see what you're going to do with this next. You're going to have to stay active in the tech club. Is that fair?
Yes, because I not finished this system. If I finish, I'm very happy to publish it, but I'm not finished.
Okay, well, it's a work in progress.
Yeah.
Okay,